Okay, let's be sensible about this. So this time I'm going to design a proper circuit um, with the right number of LEDs to maximize the available voltage. So the same situation again, we're assuming 9-volt battery, and here's my symbology for indicating we have the positive terminal here, negative terminal over here, and as the voltage goes through the circuit, we lose potential. So we start off with 9 volts and end up with 0 volts. So let's insert the first LED, and just remember that LEDs are unidirectional, so therefore we have to put the symbol in the correct direction. So positive end is this end here, and there's negative end there. So if you see this bar here, that means negative. So that's a really easy way to work it out. And remember, on the actual physical LED, the negative leg is the short one, right? So the positive leg is the long one, right? So in that case, I'll put my LED into the circuit like, I can hold this correctly like that. So positive to negative, right? Okay, so we got one LED, and these blue LEDs have an optimal range of 3.2 to 3.4 volts. So I'll do my design on the lower range of 3.2 volts, as well as the lower range of my battery of 9 volts. So even though they're sort of about 9.6 to 10 volts, whatever, we'll base it on the lower range. And that way, we'll design both the power supply and the illumination of the LED at the lower range, and we'll have consistency there, and we should have a better performance with our circuit. So we've got one LED at the moment, 3.2 volts, and obviously we can have more. Let's say I have 4 of these, okay? So let's do the calculation and see if this is going to work. So 4 by 3.2 equals, that's 12.8 volts. So that's not going to work, okay? So this is not going to be a viable solution. We need fewer LEDs. Let's try 3 by 3.2, okay, and that's going to be 9.6 volts. And also this is not viable too, because we have a 9-volt power supply. So there's a high risk that we do use 3 LEDs, that it will last for a short time, but no time at all. It will seem that it's not working anymore only because there's not enough voltage. So you're going to have to design on 2 LEDs. So here I go. I'll put in my next LED. Remember, that's negative, so that means we have the negative part of the LED there, and there's a positive end over here. And that means the only other component we need in our circuit, apart from a switch, is the right resistor. And that's what the whole purpose of this design process is to work out the right resistor to power our circuit so our LEDs last, their design life, which is thousands of hours. All right, so let's do the calculation here. We've got 3.2 volts used here, plus 3.2 volts used here. What's left over? So the first part of our design process, step 1, is to work out what is the remaining voltage of the resistor. It's unknown at the moment. All right, so voltage of this resistor, the voltage drop across the resistor, which is from here to here, right, is going to be the total voltage, which is 9 volts minus these two, so 3.2 plus 3.2, and that's 9 minus 6.4. Whoops. And we get a leftover voltage of 2.6 volts. Now, as you can see, this is less than the voltage of one LED, therefore we can't insert any more LEDs. Now, the next step of the design process is to work out the resistance of our resistor. Okay, so using Ohm's law again, there's the symbol for resistance, and this is for the resistor. We used Ohm's law, which is V, in this case, V over I, and voltage is 2.6 divided by 0.02 amps. Remember that 20 milliamps is the same thing as 0.02 amps. You must do your calculations in full volts and full amps, not milliamps, not millivolts. Okay, let's do the calculation. All right. So 2.6 divided by 0.02 equals 130 ohms. Okay, so to get the right resistor, you might actually need to have a few resistors, maybe two in series, 100 ohm resistor. So you might do something like this: 100 ohm resistor in series with maybe 40 ohm resistor, or 37 ohm resistor, or 30 ohm resistor, whatever. About 130 ohms total. Okay. And that's the design process, and you can go ahead and do this with your first string series circuit, and I'll show you in a future video how to combine multiple series circuits to form a parallel circuit. So you can have many LEDs, not just a couple. So you don't have so much the limitation of just 2 or 3 LEDs or 4 LEDs in a circuit. You can have actually many. And the way to solve that is by having a parallel circuit. But every series part of a circuit must have a resistor to control the current and voltage in that particular part of the circuit.